This video covers topics of understanding method calls and placements. A method is a program module that contains a series of statements that carry out a task. You have already seen Java classes that contain main method, which executes automatically when you run a program. A program's main method can execute additional methods, and those methods can execute others. Any class can contain an unlimited number of methods, and each method can be called an unlimited number of times. To execute a method, you invoke or call it. In the other words, a calling method, also known as a client method, invokes a called method. Consider this simple class. You guys are familiar with such classes as we developed some of those in the past. So in this class, what happens is we're using 4 different print line commands in order to create a messaging for our user. The output says, "Welcome to the class Understanding Method Call and Placement, Java Application by Ali Kararudi." So this is one way of fulfilling this task. However, instead of adding this many print line statements to the application, you might prefer to call a method that executes 3 statements. Then the program would be much simpler. To do so, I will go ahead and define my public static void method on the top. And the name of the method is anything that you want. In this case, I'm going to call it display welcome message. And then what I need to do next is to define this method. To define this method, what I'm going to do is I'm going to simply get and cut all of these lines of messaging that I want to provide. And then what I'm going to do is I'm going to paste them right over here. So as you can see, now we have that public method on the top, which actually takes care of all this messaging. If I run this program right now, as you can see, there is no output. However, what I can do is now I can call this method within the program in order to fulfill the task that that method should do. So to call the method, I simply just call the name of the method and that's it. So if I run this program now, you will see all those messages are going to be displayed again, because when we run the program, we start at line 13, which is the main, and then at line 15, compiler notices display welcome message, and therefore it goes back to line 5, and then it starts executing from there, and when it gets out of the scope, the control is going to be returned right to line 16, waiting for the next line. Remember that the main method runs automatically, while the other methods should be called. So if I don't call the display welcome message, it will never run. But the main is going to run right after you run the program. Good. So there are 2 major advantages to creating a separate method to display those lines. By including a method call, the main method remains short and easy to follow because it does not contain all those separate print lines from this method within the main. So as you can see, main is a streamlined, neat, nice, and easy to follow. The other advantage is a method is easily reusable. After you create the display welcome message, you can use it in any application that needs this information to be shown. In the other words, you do work once and then you can use the method many times. Remember that a method includes a method header, which also called declaration. So this is what we get at this line. And then there is a method body, which is between pair of curly braces. Here we open a curly braces and here we close a curly braces, right? It contains the statements that carry out the work, and also this part is called implementation. So this part is our declaration and this part is our implementation. The order in which methods appear in a class has no bearing on the order in which the methods are called or execute. No matter where you place it, the main method is always executed first in any Java application, and it might call any other methods in any order and any number of times. The order in which you call methods, not their physical placement, is what makes difference in how an application executes. A main method executes automatically when you run a program, but other methods do not execute simply because you place them within a class. They must be called. A class might contain methods that are never called from a particular application, just as some electronic devices might contain features you never use. For example, you might use a DVR to play movies but never to record TV programs. Or you might use your microwave oven for popcorn but never for defrost. Using a method name to contain or encapsulate a series of statements is an example of the feature that programmers call abstraction. Consider abstract art, in which the artist tries to capture the essence of an object without focusing on the detail. Similarly, when programmers employ abstraction, they use a general method name in a module rather than list all the detailed activities that will be carried out by the method. The method header is the first line of method. It contains the following: optional access specifier, a return type, an identifier, and parentheses. Remember to place the entire method within the class that will use it, not within any other method. Access specifiers can be public, private, protected, or package. Most often, methods are given public access. Endowing a method with public access means that any other class can use it, not just the class in which the method resides in. In addition, any method that can be used without instantiation of an object requires the keyword modifier static. The main method in an application definitely must use the keyword static. However, other methods, they also can use it, but they are not mandated to use it. You will learn more about non-static methods later down the road. Now let's discuss the return type, okay? A return type describes the type of data the method sends back to its calling methods. Not all methods return a value to their calling methods. A method that returns no data has a return type of void, as you can see over here. Remember, within this method we never returned any data back to the caller, and therefore this is void. Other methods that you will see later have different return types. The phrase void method and method of type void both refer to a method that has a void return type. Next logical step is to talk about a method's name. A method's name can be any legal identifier. That is, like identifiers for classes and variables, a method's identifier must be one word with no embedded spaces and cannot be a Java keyword. The method that executes first when you run an application must be named main, but you have a lot of leeway in naming other methods that you create. Technically, you could even name another method main as long as you did not include string within the parentheses. But doing so would be confusing and is not recommended. Because methods do something, that is, perform an action, their names frequently contain a verb such as display welcome message. Every method header contains a set of parentheses that follow the identifier. The parentheses might contain data to be sent to the method. For example, when you write a main method in a class, the parentheses in its header surround string arguments. The display address or show message method in the class that we developed require no outside data, so its parentheses are empty. Basically, when you want to run this, You really don't need to pass any information to the method, and therefore within the parentheses, you have no input data. The full name for display welcome message method is going to be tutorial dot display welcome message, which includes the class name, a dot, and the method name, which is display welcome message. The name does not include an object because display welcome message is a static method. A complete name that includes the class is fully qualified identifier. When you use a method within its own class, you do not need to use the fully qualified name, although you can, and I'm going to show you how. Okay, let's come back here. What I'm going to do is I'm going to add a tutorial to the beginning of this name with a dot. Okay, so now as you can see, the fully qualified name or fully qualified identifier for this method is actually tutorial, which is the name of the class separated with a dot and the name of the method. And if I run this again, you see it runs as is used to run. But you definitely noticed when you're using the method within the same class, the tutorial dot part is not necessary and I can get rid of it. However, if I'm using this method within another class, I definitely need to use the fully qualified identifier, or I'm going to receive an error because in that case, compiler does not recognize the method unless it uses the full name. You should use similar syntax, including a class name dot and method name when calling other different Java methods in the past. Remember that we used Java option pane.show message dialog box method in the past, which was of the same concept. Based on this fact, you can have many classes that they all have a function called display welcome message. And the only difference between these display welcome messages is the class that they're residing within. Let's say we have class tutorial, and then we don't have it, but we just consider that we have a class named other class. Okay, if we have another class, that other class can have a display welcome message method exactly as the one that we have over here. And these two fully qualified names are actually referring to absolutely different classes. Remember, the reason that you see that under error is because that class actually doesn't exist. I didn't create that. But I believe you get the concept. Think of the class name as the family name within your own family. You might refer to an activity as the family reunion, but outside the family people, you basically need to let them know what are the last names. As in, like Anderson family reunion, you have Anderson, James Anderson, and all that, but you can have Cooper's family reunion, and you have James Cooper, which is from that family reunion. So, in order for everybody to understand which James you're referring to, you have to name them James Anderson or James Cooper so they actually understand it. Some methods require that data items be sent to them when they are called. Data items you use in a call to a method are called arguments. When the method receives the data items, they're being called parameters. Methods that receive data are flexible because they can produce different results depending on what data they receive. As a real-life example, when you make a restaurant reservation, you do not need to employ a different method for every date of the year at every possible time of the day. Rather, you can just supply the date and time as information to the person who carries out the method. The method recording the reservation is then carried out in the same manner no matter what date and time are supplied. Also, in everyday life, you use many methods without understanding how they work. For example, when you make a real-life restaurant reservation, you do not need to know how the reservation is actually recorded at the restaurant. Perhaps it is written in a book, marked on a large chalkboard, or entered into a computerized database, or any other thing. The implementation details don't concern you as a client. And if the restaurant changes its method from one year to the next, the changes does not affect you to use the reservation method. You still can provide your name, date, and time and get the reservation done. Similarly, object-oriented programs use implementation hiding, which describes the encapsulation of method details. So in this case, anything that goes over here in the implementation of the method is hidden from the user of this method, who's going to call the method through just understanding the name of the method and the parameters that are actually being entered. Implementation hiding means that a client does not have to know how a method works internally, but only needs to know the name of the called method and what type of information to send. Usually, you also want to know about any data returned by the method. You will learn about return data later in this video. In other words, the calling method needs to understand only the interface to the called method. The interface is the only part of a method that the method's client sees or with which it interacts. In addition, if you substitute a new or revised method implementation, as long as the interface to the method does not change, you won't need to make any changes in any methods that call the altered method. Hidden implementation methods are often referred to as existing in a black box. Many everyday devices are black boxes. That is, you can use them without understanding how they work. For example, most of us use phones, television sets, and automobiles without understanding much about their internal mechanisms. Okay, now let's take a look at how we define a method with the arguments passed into it. So we start from here. The first step is going to be to define the access specifier, which in this case is public. Next step is defining the return value, which I decided the return value of this method to be a float value. And then we set a name. As we said, this name should not be a Java word or any reserved or illegal word. So I just called it calculate something. And there's a reason behind that, because I want to show you that through implementation hiding, we really don't need to know what happens inside. If they're being added, subtracted, multiplied, you really don't need to know, as long as you know you have to call the calculate finding or calculate something. So for the data types, and notice here, this is something new. So what we do within the parentheses, we define the argument that should be passed to this method. And in this case, we define that a float A and a float B are going to be passed to this method. So within the method, on line 6, I'm defining a float result of something. And for this case, I'm going to set it to be A plus B. Anytime you have a method with a return value, as such we have over here, you need to use the keyword return and basically return a value of that type out. Notice that the result of something is a float according to this line over here. And what I'm doing after all the calculations, I'm returning the result of something back. So let's talk about this a little bit. Whether or not a method can receive a parameter, its declaration contains the same elements as one that does not accept a parameter. So we need optional access specifiers, the return type for the method name, and a set of parentheses. However, if a method receives a parameter, 2 additional items are required within the parentheses, which are the parameter type and a local name for the parameter, in this case float A. If you want to have more than one parameter for one method, then you just separate them with comma, and then the order of the passing is going to be exactly the order of the parameters. So at this point, we have defined a dynamic method for ourselves. But since we are using with this method in a static mode in this program, I'm going to go back and turn it to be in static with adding the static over here. We're going to discuss this later. And now I have a static method. To call the static method, the only thing that I need to do is I have to do calculate something, just call the name. And notice that now I can pass two different variables to calculate something, A and B, within the same order. So I'm going to pass 4 and 5. So what happens after I run this command is that 4 is going to pass over here, and A is going to be assigned to be 4. Therefore, 4 comes down here. Same story with 5. 5 is going to be passed, and notice that the order is important. So 4 is going to go for A, and 5 is going to go for B. I could have done this, and then 5 would have been going for A, and 4 would have been going for B. And then the A plus B calculation is going to happen, and then the return value is going to return back. To catch the return value, I need to save the result of this call somewhere. But before I do that, let's run this pretty quick. And as you can see, it runs without no error, but there is nothing happening after this line is being executed. Actually, something is happening, but we cannot see it because we're not storing it anywhere. So what I'm going to do is I'm going to go ahead and within my main, I'm going to define a float result and set it to be 0. Okay. And then over here, what I'm going to do is I'm going to set result to be field with the result of that calculation. And on the line after, what I'm going to do is I'm going to simply just print out result. So it's going to be system.out.println. And what I'm going to do is simply just putting result in there, okay? And there you go. So now if I run this program, what you're going to see is the result of 4 plus 5 is showing up over here, 9. Okay, so let's go ahead and see what happens if somebody changes the implementation over here. So if the implementation gets changed, and now we have A minus B instead of A plus B, notice that from the perspective of this client over here, which is calling calculate something, no change has happened, but the result will be absolutely different. If I run this, the result is now going to be 1 rather than 9, because now it's 5 minus 4. So in the same way, if they change it to multiplication and we run it again, the result now is going to be 20. So as you notice, as long as the interface of the method is unchanged, the function calls or method calls to that specific method could remain intact, and this means implementation is hidden from the caller, which is calling from down here. Sometimes if you pass wrong parameters, let's say if user just does this, like passing an A in there, okay? So as you know, that function is basically looking for a float. Let's run this, and as you can see, now you have a 325 as the result, which basically means number 65, which is Unicode equivalent to character A, is now being considered over there. Like let me just change this to 1 so you can see the Unicode value for character A, which is 65, is actually being passed over there. So in some case, like this one, it works because we have an equivalent, but let's see what happens if we send string literal over there. If I run this now, I'm going to get an error because of the fact that this one cannot be parsed into a float the way it is. And therefore, if compiler is not able to parse something to a float, in our case, you're going to receive an error. Otherwise, you're going to have a result. Doing it this way is really absurd. Nobody does multiply 1 by b, but just wanted to show you that as long as the parsing can happen, you have a result, but if you don't have a parsing, then you don't have a result in that case. So pretty straightforward. You have an interface which defines how to use the method, and the implementation inside is hidden from the caller. As you noticed, A and B are only being used within the scope of this method over here, and we don't use them anywhere else in the program. So they only live and act within the scope of that method. And therefore, we call it a local variable to calculate something. So you're going to see that A and B are not accessible anywhere outside the program. Like I say, B equals 5. This is not going to be acceptable by the compiler because B is unknown. If I define an integer B in here, this integer B in here is going to be absolutely different from the B over here. Okay, so always remember the parameter names that you define in the header of the method and you use it within the method are local variable to the method and are only accessible within the scope of the method. Okay, now let's practice, and what I'm going to do is I'm going to just copy and paste this thing again, and this time I'm going to put it 10 and 5 so that you notice that you can recall the method times and times and times again. And let me just go ahead and get rid of this for now because I don't want those messages to pop up all the day. And if I run this, you see it gives me 20, 50, so it depends on what parameters you sent there. You can call this method as many times as you want, and each time this method being called, the new parameters are going to be passed up here, and then those new parameters are going to substitute A and B in the calculations. The calculations will happen and the result of that thing is going to be sent back. Okay, let's quickly review. A method can require more than one parameter. You will list the arguments within the call to the method and you separate them with commas. When you call the method, arguments are sent to the method and they must match the parameters list in the method declaration by number and type. For example, if we call to our method over here and do something like this, now we have an error because the number of parameters and arguments we're passing to the method are more than what it is expecting. And I also showed you if you are passing something that doesn't work in the type, you still get an error because you're not supposed to send it back. So it always should match in the number and the type, okay? And in this case, it looks like we're sending integers, but by default, it considers that you're sending something like this, okay? That's just how the compiler goes and decides over there. So a method signature is the combination of method name and the number, types, and order of arguments. Therefore, you can say that a method call must match the called method's signature. Okay, now let's look at something very amazing over here, and that's the fact that you can call a method within a method. Like, let's say after I calculated the result of something, I want to display our welcome message, okay? So what I can do is I can basically call display welcome message from within this method. So notice that that's a method which is defined within the scope of the class. Because it's within the same class of tutorial, I can call it over there. And let me just get rid of one set of these lines so that you can only see one call. As you can see, the only thing we do in the main is we set a result to be calculated something of 4 and 5, and then we print it out. We never called the display welcome message within main, as you can notice. But if I run it, you see that, let me just pull this up so you can see the result. Yes, you see that everything in display welcome message happened and then the result happened, and that's because when the control starts at main, let's follow the control. It starts at main, sets the float result to 0, comes down here, sets the result to be calculate something of 4 and 5, and as soon as this happens, we come back all the way up here and we start from this point. We get A and B, multiply them, and then we arrive at this line calling display welcome message. So then control is going to jump over here and goes through display welcome message, bam, 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 all the 4 lines are being executed till we get out of the scope on line 17. At this point, the control is going to go back to where the method call happened. So the control come back all the way over here, right after this guy, and then returns the result of something, and the scope is over, which at this point controls comes all the way back to the end of this line, and therefore it goes to the next line, system.out.println result, which the result happens. It's kind of like a chaining method calls that can happen from within a method for another method. You can do this as many times as you want and as deep as you want. You can call this one, and within this one call another method, and another method. So as you can see, very useful for when you want to reuse parts of implementation, and it's going to make your program very manageable, because every time you have an issue or a problem or a bug or something, you have a small chunks of code called methods that you can go to there, fix that, and the entire program is going to get fixed. It is amazing because your code is not scattered around. And finally, I want us to take a look again at the return statement. Remember, return statement causes a value to be sent from the called method back to the calling method. As you noticed in our example, we had result receiving whatever the return statement was sending back. The return type can be any type used in Java: primitive, class type, or being void, which means there is no return for nothing. Which, if you have a void method that has no return value, you really don't need to use the return statement anyway. And then the method's type is basically defined by a method's return value. So for example, over here, the method type for this method is void, and the method type for this method is float, okay? And you notice that the return is just returning one from the float type. If you don't include the return in a non-void method, you're going to receive an error telling you that, hey, you need to add a return statement over here because you just defined it to be void. If you go to a void method and define a return void, then you're causing a very confusing situation for the compiler. So if you notice at the message, it says void methods cannot return a value. So remember, despite the fact that we understand the return type is void, but you don't need to include the return void, or you're going to get such an error that you can see on this page right now. So I'm going to delete this and get rid of it for us. Let's run the program once again and make sure everything is good. And this basically was everything that I wanted to discuss about the methods. The next logical step to this is going to be talking about classes and objects, which is going to come in another video. Thank you for watching.